Hey everyone, and welcome to This Explainer. Okay, so today we're unpacking a historical document that honestly completely reshaped our entire globe. We're going to be diving into a story that sits right at the crossroads of high-stakes geopolitics, some truly devastating human consequences, and believe it or not, a massive scientific mystery that completely drove early mapmakers up the wall. Right off the bat, we got to ask ourselves a tough question. Was the Treaty of Tordesillas actually about peace? Or was it just a naked grab for power? Think back to the late 1400s. Right after Christopher Columbus does his first voyage in 1492, Spain and Portugal are in this dead sprint to claim all these newly discovered lands. They're the two biggest heavyweights at the time, and they are basically on a collision course for a massive, full-scale war. So to avoid that, what do? They go to the Catholic Church. And the solution they come up with in 1494 is, well, it's pretty wild. They literally sign a treaty to draw an imaginary line straight down the Atlantic Ocean, about 370 leagues west of the Cape Verde Islands. Okay, let's dive into this and see how it actually played out. This unprecedented agreement basically just carved up the whole globe into two giant spheres of influence. It's kind of crazy when you think about it. Spain gets everything west of the line, which ends up being the vast majority of the Americas, and Portugal, they get everything to the east. That means parts of Africa, Asia, and eventually Brazil, which just happened to peek over the eastern side of that boundary. It was an astonishingly bold way to split up the world. Now, as you might guess, the on-the-ground reality of this treaty was anything but peaceful. It basically gave these European powers a blank check to just take over vast territories, almost always by force. You've got Spanish conquerors like Hernán Cortés and Francisco Pizarro literally using this exact agreement to justify brutal invasions of established, powerful indigenous empires, like the Aztecs and the Incas. And the human toll here is absolutely staggering. We're talking millions of indigenous people killed by violence and introduced diseases, subjected to forced labor, and seeing their entire societies, cultures, and governments just completely dismantled. So when we zoom out and look at the sheer scale of this treaty, it really forces us to ask, well, whose voices were completely missing from the room? This sweeping agreement dictated the future of entire continents, right? But it was negotiated without consulting a single indigenous person, not one, even though they had lived on and governed these lands for thousands of years. This was purely a deal struck by European monarchs and the church, just entirely ignoring the sovereignty of the native populations. And, when you're analyzing a historical document like this, you really have to read between the lines. The official language uses words like discovery and division, but that was actually a really convenient way to conceal the incredibly violent realities of conquest. It challenges us to look closer at historical narratives, right? History isn't just some neutral record. It's a story, and it's deeply shaped by bias and whoever happens to hold the power. Calling it discovery makes it sound like this peaceful, almost administrative task, neatly hiding the brutal, true cost of colonization. But here's where things get really interesting. Because sure, dividing the world on a piece of paper is one thing, but actually going out there, navigating and mapping it, totally different story. Let's move to and see how this builds into a massive scientific headache, something called magnetic declination. Early sailors called this the variation of the needles. Simply put, it's the angle between magnetic north, which is where your compass actually points, and true geographic north. Because the Earth is a sphere and its magnetic field is super complex, your compass almost never points exactly to true north. Now, what's really interesting about this is seeing exactly how that magnetic headache actually showed up on early maps. Take a look at the Continental Planisphere from 1502, which is one of the earliest charts we have of the African coast, and compare it to a modern, accurate map. Do you see how the entire continent of Africa looks stretched, like it's being pulled way out eastward? The Isthmus of Suez looks absolutely enormous. And that distortion is happening entirely because early chart makers were literally drawing these maps using uncorrected compass courses that pilots are bringing back from sea. To really understand why this was happening, we have to look at how these early sailors were actually finding their way. They basically relied on two methods. First was the point of fantasy, which is an awesome name, but it really just means dead reckoning based purely on course and estimated distance. The second was the set point method, where they'd combine their compass course with their observed latitude. But, and this is the kicker, when they ignored magnetic declination, both of these methods massively skewed their apparent longitude. So when mapmakers transferred those raw, uncorrected compass headings onto a flat map, regions with high magnetic variance, like the Atlantic and Indian Oceans, ended up completely, wildly warped. And here is where bad cartography triggers a massive geopolitical crisis. Because these maps were stretching the world so far eastward, they accidentally pushed the lands in Southeast Asia further east on the chart too. The result? Portuguese maps completely misplaced the Moluccas. These were the spice islands, literally the ultimate prize in global trade at the time. The maps wrongly placed them about 8 degrees inside the Spanish hemisphere. So, believing these completely distorted maps, Ferdinand Magellan goes straight to the King of Spain and confidently promises, hey, I can reach the Spice Islands by sailing west, and they legally belong to us under the Treaty of Tordesillas. It's a bold pitch. In 1519, Magellan's fleet set sail, but cut to 1521. After surviving an absolutely brutal crossing of the Pacific, the fleet's cosmographer, Andres de San Martin, actually takes precise astronomical measurements of longitude while they're in the Philippines. And those measurements kick off years of intense debate between the Spanish and Portuguese crowns, finally ending in a political agreement in 1529. So, the absolutely crucial point here is what San Martin actually discovered during those 1521 measurements. The shocking truth? The region was actually 9 degrees inside the Portuguese hemisphere. I mean, no way, right? You can just imagine the sheer, utter panic among Magellan's crew. They realized the magnetic distortion on their maps has completely tricked them. The entire mission, which was meant to claim the Spice Islands for Spain, was potentially illegal under the exact treaty they were trying to enforce. Talk about an oops moment. Eventually, though, the experts of the day start piecing together what was actually going wrong. Navigators and mathematicians, guys like João de Castro and Pedro Nunes, finally realized that these uncorrected compass courses were fundamentally breaking their maps. It's like a giant puzzle they couldn't solve until they realized the pieces were shifting. In fact, an early 16th century pilot named João de Lisboa flat out said, the coastlines on nautical charts are faulty by 1/4 or 2, which means they were off by as much as 11 to 22 degrees. They finally knew for sure that the variation of the needles was completely messing up their geographic reality. But actually fixing it, that was incredibly complicated. If you track the mapped longitudinal distance to the Cape of Good Hope over time, comparing historical map data to the true distance, you can see a really clear trend. Just notice how, slowly but surely, as we move through the 16th and 17th centuries, the chart makers are recognizing their errors. The spacing steadily drops down, getting closer and closer to reality. And this brilliantly illustrates exactly how they did it. Looking at the mapped distance to Cape Guardafui in East Africa over that same period, you can see the accuracy improve. Instead of constantly trying to twist and turn the drawn coastlines to match ever-changing compass readings, mapmakers did something smart. They quietly started ignoring the compass directions when drawing the map. Instead, they began relying on accurate astronomical measurements of longitude, like timing lunar eclipses, to fix the distances between places. They were finally prioritizing hard geographical reality over raw compass data. By updating their charts with these precise latitudes and the newly corrected astronomical longitudes, cartographers were essentially forced to adopt a whole new system. It was an early grid-like layout known as the plate carré, or cylindrical equidistant projection. This was a massive shift, literally a real game changer. The meridians and parallels now formed a regular mesh of squares. Now sure, a straight line drawn on this new map didn't perfectly match a compass course anymore, but it was geometrically consistent, and for science, that was a huge leap forward. But they still had to make these new grid maps mathematically safe for the actual sailors using compasses out on the water. They had to innovate. Which brings us to this breakthrough chart from 1676 by João Teixeira Albernaz II. If you look closely at the details, you'll see a scale bar that actually has multiple distance scales for 8 different latitudes. The cartographer essentially solved the mapmaker's dilemma by adding these varying scales so sailors could accurately calculate distances, no matter how far north or south they were. It was just a brilliant, highly practical solution to a problem that had plagued them for centuries. As we wrap up this explainer, I want to leave you with a bit of a provocative thought. Can the Treaty of Tordesillas actually be seen as an early example of international law? It's a document with this incredibly complex, really dual legacy. On one hand, it was this breathtakingly arrogant division of the world that acted as a catalyst for devastating human conquest and suffering. But on the other hand, the geographic confusion it created accidentally sparked a navigational and scientific revolution. It fundamentally changed how we understand and map our entire planet. It really just goes to show how history, much like those early maps we looked at, is rarely ever a straight line. Thank you so much for joining me on this deep dive.